treehouse detectives. Are you Miss Ryan?
Yes, how can I help you today?
We're designing a lift chair and a pulley system to help get our friend with the broken foot up into the treehouse. And we want to make sure that it is safe to use.
Well, you've come to the right place. I am a safety engineer here at NASA Langley Research Center.
What does a safety engineer do?
Well, we do lots of things, like evaluating projects or jobs to identify potential hazards or risks. We also develop safety plans and guidelines that help prevent harmful accidents, incidents, or mishaps.
Wow, that sounds like a cool job and lots of responsibility.
Yes, and we're doing more than developing rules. We're actually protecting people, property, and the environment.
And we need to protect Jacob. What are some things that we should consider?
How much will you be lifting?
About 120 pounds.
You'll need to know if there's a load limit on the ropes, pulleys, or anything else you will be using in the lifting process.
We hadn't thought of that. How do you figure out the load limit?
Most of the time it's printed on the packaging of a product. If not, look for the manufacturer and contact them directly.
We will definitely do that.
Is there a safety catch on your pulley system?
No, I don't think so.
A safety catch or a locking mechanism of some kind are very important in case the people pulling the rope lose their grip. It would catch and stop the fall of the chair.
We have a lot to check out and to research.
Also, make sure your equipment is in good working order. You don't want to use worn or broken equipment.
And don't forget that we have to make sure the tree limb is strong enough to support Jacob, the lift chair, and the pulley system.
Now you're getting it. And don't forget about testing your equipment before you lift anyone.
We will be sure to test everything.
You'll also need to consider human factors. While you're here at the center, you should talk to Dr. Carla Torella. She's a human factors engineer.
Great!
I'll give her a call and let her know you're coming.
Thanks!
You're welcome. And good luck with your project.
Oh, hi Catherine. Laura Ryan said you'd be stopping by. Have a seat. How may I help you?
Our friend Jacob broke his foot, and we've designed a lift chair to help him to get into the treehouse. Miss Ryan gave us some good suggestions on how to make the chair safer, but she said that we should also consider the science of human factors. She said that you could help us with human factors.
I sure can. Human factors is the design of things, spaces, and processes so they fit better with people in terms of how people are designed physically and how we process information.
Why is it important?
Well, when things or processes or areas are designed without considering human factors, they may be really difficult to use, and so they may not be used at all.
So where do you start?
Well, we start with standards and guidelines that are based on scientific principles. And for example, they help us understand how the eye works, which would help us understand what colors to use in our displays.
Oh, I get it.
Then we use what we know is good for human operators, and we get real operators involved in the process. This is called user-centered design.
What are you working on now?
Well, here at NASA Langley Research Center, we design displays and aiding technologies for airplane cockpits. We do user-centered design of these concepts by involving real pilots and testing them in aircraft simulators like this one, the IFD.
What is the IFD?
The IFD is Integration Flight Deck. The IFD is a copy of the flight deck on the NASA Boeing 757.
We learned that in designing, you have to use the iterative process, where you test, evaluate, and redesign. Human factors is sort of like that.
Yes, that's right. The iterative design process is an important part of user-centered design. You want to involve users all the way through the process, from concept formation all the way through to testing in a real environment.
What kind of human factors should we consider for our lift chair?
Well, first you need to define your user population. Will Jacob be the only one using the chair, or will other friends use it as well?
We hadn't thought of other users. It would be nice to have for other people who might need to be lifted.
Well, you need to consider your users' requirements, the design goals too. So they may be safety, comfort, usability.
Anything else?
You need to consider the anthropometric characteristics of your users.
Anthropometric? What is that?
Anthropometry is the study of measuring people. There's static measurements such as arm length and height, and then there's functional measurements such as viewing angle and reach.
Wow, we have a lot to consider. Thanks, Dr. LaTorella.
Oh, you're welcome. Let me know how your chair works out.